Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So, thank you very much, and thank you for all your feedback and suggestions. And I think that after this talk on analytics, you're actually going to have some more, because I'm going to switch a little bit from the focus on single puzzles to the focus on lots of puzzles and what happens when you have got lots, and how can you use all these puzzles and make a big experience out there for everybody, and then for yourself once you get the data back. So those are the two things. You've got the puzzles, you want to actually get them out there to the world, and you've seen a small experience of that. But now how do you get the data back and use that data, perhaps in a feedback loop, or perhaps just for your own research? So, summarizing what CodeHunt does for you is, and other platforms like this, gaming platforms, is that they enable you to actually work at problems you otherwise wouldn't work at. It's this old thing about learning how to play the piano. You need 10,000 hours, they tell you. Well, if it's fun and people make it fun, you actually put the work in. And learning to program is one of those things. If you can make it more fun, and discovery is a powerful driver for that, and gaming, which is in CodeHunt, joins these both up. Now, one of the biggest gaming platforms is the ACM programming contest, which is highly regarded, quite respectable. It's been going for a very long time, but CodeHunt is completely different to the ACM programming contest. So the reason being that the ACM programming contest tells you what to do. It says, here's a specification, solve the problem. Now you might say, well, it's fun solving problems, but that is not the way that CodeHunt works. CodeHunt says, there's a problem out there, what is the problem? So it's a little bit more like detective work. And as you were told earlier, it's all built on top of PEX for Fun. Now, when we started this whole thing, we realized that, in fact, we had different audiences. And I think this is important when you've got a research project. You can't be having one size fits all on everything. Obviously, it is one size. I mean, there is only one project, but different parts of it talk to different people. So we've got the coders and students out there. And when I talk about coders, these are people like the developers. We have a lot of developers who use this. It's not just students. We don't know who's actually using it, but we know they're not just students. We have educators, and we're not currently servicing educators in a big way. We hope that at the end of this workshop, that we will be on a path to have a plan for educators. Recruiters. Now, within Microsoft, you might not be totally aware of this, we have people who recruit students, and they're using this platform now, ever since September. So they're watching what's going on in this platform and seeing who are the top coders, and they treat these people a little more, especially when they go out to the universities. So researchers also, and this is the main thing that we want to do, mine extensive data in Azure, and we can then evaluate how people code and learn. So to give you some idea of the data, we've had several hundreds of thousands of users since March. March is when we really kicked off this platform. So it was about March the 3rd. And we can take statistics at any time over any period. It's all worked. And here is a picture which was over a period from September to October. So it was about a 1-month period. And what it's showing is the loyalty of users. So this is one thing on the website. It's one thing that Visual Studio website gives you. So the blue figures are new users, and the purple ones are returning users. And if you've got about a 50%, which this one is showing you have, then that's considered to be pretty good. So you've got a lot of people coming in, and you've got existing users staying on the platform. And this is a good thing. Oops. Here's some figures about languages and also about the global interest on Code Hunt. Now, this changes from time to time. It all depends where the contests are. But as you can see, Polish at this time was a huge interest because we were running contests in Poland at that time. It's dropped a little bit. Also, Brazil, which is Portuguese up there, they seem to have picked it up all on their own without us doing anything. And so there's a big interest from Brazil. And we'll have another bigger interest from China when we start the Chinese competitions in April. So globally, you can see the effect here. Europe is bigger at the moment, or at that time when we were taking the data, than North America was. So that is telemetry data which is on the website. We're just reflecting what's going on the website. We also have other data which we mine, which is at any time people can answer a 10-question survey. So you're welcome to answer it. It's a little feedback button on the right-hand side of the website. And some of the questions in there are interesting. I wrote the questions, and I wrote them in my particular style. They might not be particularly, they might not pass a test for the best way for writing questions, but I said, how much did the puzzle aspect of Code Hunt keep you interested in reaching a solution? And as you can see, a lot and quite a bit, if you add those two numbers up, come to 83%. So the puzzle aspect kept people interested. Then the next one I was interested in, out of the 10 questions, was, were your final solutions well-structured code? In your opinion, right? And the answer came back, 77% felt their code was good. So not only did they feel it was good, but I put the little piece in there. I kept tidying my code up. So they're not submitting rubbish just to get the answers. That was what I was trying to get out of people, right? But at least 15% said there were extra statements in there, which they just left. So these are interesting, but these particular statistics were not really relevant to contests that we're doing. So for contests, what we want to do, and this is where the rest of the talk will move to, is we want to identify top coders, and we want to make these competitions fun. Now, the little green and orange block here is what motivated us to move into this area. So our Chinese outreach colleagues were running a competition, and they asked us to help them with this competition, and would we use Code Hunt alongside the ACM programming competition? So we did. And what happened was that of the over 2,000 players in the competition, we saw that there were 41 average tries per player across all puzzles, across all players. That was just a raw figure that we could extract. But if we took the top 350 players, and that was just a place where we drew a line, the number of tries was just over 7. So it seemed as if in this big competition, number of tries, for whatever reason, and we have been discussing reasons as to why tries might or might not be a measure, but for whatever reason, it was an indicator in this competition, and there were 4 sessions in this competition, so it went on a while, was an indicator of top coders. So we decided to stick with this measure. And since then, we've had 15 competitions, and I'll tell you a bit more about them. Some of them have had only about 12 people in them, and some of them have had 13,000 people in them, but crazy. We've got regional contests around the world, and we've got Imagine Cup contests. So Imagine Cup is a big event that Microsoft runs, and Code Hunt is part of that on a monthly basis. Now, how do we create new contests? Let's give you some insight into this whole process. It would be wonderful if puzzles fell from the sky. Unfortunately, they don't, any more than exam questions fall from the sky. I think for those of you who are educators, it is exactly the same kind of exercise you have to go through. You have to think of a problem, and you have to think of a new problem. And you have to think of an appropriate problem. And you have to be good at thinking of problems. So we didn't force that on you today. We gave you problems just to amend. But we've got a couple of people who think of new problems, and then we've got to put them in a bank. And although it says 250, we're up to 300 now. And for each puzzle, we have properties. And tomorrow we'll be showing you live what the bank looks like on a live tool that we've been constructing. So on the right-hand side, you'll see the kind of things that we record. We record a puzzle number. We have 5 categories. Very, very simple. Numbers, arrays, strings, bools, binary. That's it. And that's the kind of puzzle it is. Then we have the description. That's highly secret. For the first time today, you've actually seen some of those descriptions, but before today, we've never let them out because that would spoil the game if anybody got to see them. So please don't tell people about those. Then there's a key that says who wrote the puzzle, and then a number, 2. What's that? That says how difficult we think the puzzle is on a scale of 1 to 5.
How's that?
Right, so that is a thumbsuck. It is the person who's doing it and has been doing puzzles for a long time says, this is a 2, right? And this is going to be the crunch of what I'm going to tell you in a minute. Then we create a lot of contests. Now, because I'm the one who uploads these contests, in the same way as you've just uploaded one, I get to see lots and lots of contests. So these are a lot of contests that I can see. You can see the Poland one, you can see a lot of Imagine Cup contests there, and various other ones. So I can actually go in there and check the results of those contests. Once I'm in any one of those, as you know, I can check also the leaderboard, which is public, and the dashboard, which is private to the owner of the thing. Now, when we've got these, a contest is over, we update in the bank the fact that the puzzle was used in that contest. Now that's important because in certain cases we don't want to reuse a puzzle, or we don't want to reuse it immediately. Maybe we'll reuse it in 6 months' time or something like that. So there are various strictures. It's just like an exam question. Then we modify the difficulty. So great question there, Mark. The subjective difficulty needs modification. And how do we do that? Well, we've got 2 options. The one is, well, we could modify it based on how the user scored on that puzzle, or we could modify it based on the number of tries. And we decided to go for the tries because it depends on the mix of students who enter. It also depends, unfortunately, on the internet speed, so that's a disadvantage. And it also depends on whether students use an IDE. So they go offline and then they come in. So they might only have 2 tries, but they've actually worked on the puzzle a lot. So it's a bit of a disadvantage, but for the sheer numbers that we have, we think we're winning on this metric. So now you're going to have all the writing. This is the formula we use that we publish. It's not secret. It's the perceived difficulty. And what happens is that we calculate this, we multiply it by the number of people in the contest, and we replace the difficulty by this new difficulty across all contests at that time. So the difficulty is updated after each contest. And I'll show you how spectacular that can be or how incremental. Yeah.
So why tries and not time to solution, which, from what we've heard, seems like a better measure of...
Which?
Time to solution. How long
you see, we specifically never use the time to solution because people can go to the bathroom. It can be nighttime where they are, it can be midnight, they go to bed, they come back. We specifically never ever use time. So
like the kind of things that would affect time are the kind of things that if you have a large number of users, they would average out. Versus with tries, it seems that it's easier to get systematic biases based on, one group of people who's just accustomed to pressing Control S every time, for example, every time they type something.
We've had this discussion a lot, and time has been one of the things we really didn't want to get into, because a game is something you sit with and you walk away from, and you sit with and you walk away from. Do you want to add something there, Pelly?
We don't know when they stop playing if they're still working on it or whether they just stopped.
Yeah, Alexei?
So I have comments on time. So time works pretty well if the competition is time constrained, like it's 1 hour, 2 hours, 4 hours. So you can assume that no one goes to the toilet maybe. And imagine clubs that they last for 2 days. And people can go sleep and so on. So it's really a bit dirty metric in this case.
Yeah. Yeah, most of these contests are 2 days, which actually I'm not very keen on, but that's the way they've been set up. So, Nigel.
And there's also the complication that the person can give up on the puzzle for quite a while and then come back to it again later. So how do we add that time effect?
Yeah, we really did think about it. These time lapses are awkward to try and nail together after the event. Yeah.
You do have the timestamps for each try, right? I mean, so you could go back to the data and take a look.
We could be smarter. We could definitely try to put the pieces together.
Of course, everything is timestamped. It's recorded.
Right. So
Because you got this great suggestion earlier, Tom's right, that counting more than one try within 30 or 60 seconds is not useful.
So I think what's coming out of this is that there is scope for other ways of calculating this. I mean, I'm going to tell you how much data we've got, and all the data's there, and it can be recalculated all over again. It's not lost at all. We can do the figures again and see what happens. So here we've got the formula, which actually just looks at two things. The first one is the B tries, which looks at the difficulty of a puzzle progressively higher as more attempts are used to solve it. But the C one, it determines whether players are improving their solving skills as they progress. And so distance means how far are you in the actual game? And you multiply by that. And also the set of players at that stage is getting progressively smaller, as we'll see. So that is taken account of there. So here's a nice table. We've got two different real contests. So the first one was the China contest here, where we had 4 rounds, qualification, preliminary, and semi-final. And the subjective difficulty was there, and the perceived difficulty was very, very similar. All right? And players who started, as you can see, there were a lot of people in the game. Now, we then had another one where the two communities here, students and teachers, did exactly the same contest. And the formula produced somewhat different results and also fairly higher results. But the problem here was that the numbers were very much smaller. So you probably can't trust those results as much as you can trust the other ones.
What was the N for this one? Do you know? What was the N for the second one? The number of people?
They're right on the far right there.
Oh,
So we had 61 and 14, very small numbers in those contests.
When you say perceived, you mean your calculation, right?
Yeah, the perceived difficulty. I just want to show you one more which I put up here. So here is another one. So this is a contest that we ran, and these are the kind of results that come out at the end of a contest. So these are the puzzles down here. So this is the one that you were in, Alexei and Jürgen. You tried this one. And these were the original difficulties. And this is what came out of it. So you can see that down here, there were two puzzles that had an average of 9 or 18, whereas we thought they were difficulty 2. Okay? So that will get folded in back into the difficulties. But we didn't have a lot of people in this contest. So there's not going to be a huge impact of that on it, as much as there would be on some other contests where we had 800 people. And there was really quite a bump in the thing. Now, we have another piece of data, and that is we have in CodeHunt, as you know, this is probably the most well-known part of CodeHunt, and that is the default zone, otherwise known as, but among ourselves, as the APCS zone, because it teaches computer science and it's got 129 puzzles and it goes through all the details of computing. Actually, 45,000, we're up to about 75,000 users have started this zone now. And you get a very steady drop-off of people on it. So they start and they drop off. The drop-off will be very similar. I'm just waiting for the data to come out of the computer, Daniel. Right, and then I'll be able to draw the new graph. Now, what we did, and this is a pretty difficult graph to understand, but let's see if we can do it. That blue line is the same as what I've just shown you. All right, so the blue line is that line. So I'm indicating at a somewhat bigger scale the drop-off rate here. And then I'm indicating with the orange bars the percentage of 1,000 winners who dropped off, all right, because of the previous, who changed between two levels, right? So the steep drop-offs. Here's a good one. You can see this one. You see that steep drop-off? And that's how much it was. So we then tried to find out, well, what was actually in that puzzle that caused that steep drop-off? Did it turn people off because that was just an unhelpful puzzle? And we discovered commonalities among these puzzles that caused these drop-offs. It was quite startling. I'm not saying it's definitive, but it was startling. The yellow ones, consistently, and these are right at the beginning, so these were beginners and these were large numbers of people. The yellow ones, that's this one, this one, this one, and this one, all involved puzzles with division. Simple puzzles with division. X over 10, 10 over X, that kind of thing.
Integer division? Integer division.
Yeah.
Yeah,
Yeah, any kind of division. It wasn't, model or something like that. It was just plain division. So they didn't do it. The blue ones were operators, such as binary operators. So those were these ones here. And people didn't think of those puzzles. So I think they didn't think of those patterns and therefore couldn't solve the problem. And the green ones were sector changes. So when you switch from one sector to the next sector, sometimes people just gave up at that sector and said, oh, well, I've finished a sector now, I'm not coming back.
Also often a sector introduces a new concept.
Correct, yes, correct. So, they might be moving on to loops and they might not know about loops and the sector says loops and they say, oh, what's this all about? So they don't go on, right? In order to keep people on the game, we do need to have results and rewards. So, as we've discussed among ourselves already, our ranking on the leaderboard, the public ranking and so on, and the way in which the rules are written for a contest, it's always based on score. It's not based on time or attempts, except insofar as if you're the first there, that breaks a tie. Now, the score is based on how many puzzles solved, how well solved, and when solved, and that's the order in which the ratings are. We're very keen that rewards should be given. So automatically, for example, in the Imagine Cup contests, there's a prize. In fact, Imagine Cup gives $1,000, and then they send out certificates. And we think that actually there should be more of this. So what we're proposing for the new Code Hunt Zone, which will be coming out soon, is that there'll be more certificates that go out for achievement during the playing of the game. So maybe if you get past 2 sectors and then you get past another 2 sectors or another 1 sector, you automatically get a certificate. So we're interested to hear what you think about that as well. We think achievement is quite a good thing. This is the kind of data that we extract out at the end of a contest. So this was the September contest. The names of the people would be here. And as you can see, this is the score. And this is the number of levels that have been solved. And then we record everything across for every puzzle. So it's an enormous spreadsheet that we deal with. And that then goes over to our recruiters, and they get the names of the people, the universities they're at, and they do something with it if they'd like to. What's the size of this data? Well, it's a lot bigger than we thought. So at the moment, we've got all these contests that have run. At a minimum, we've got 725,000 or more people who have begun the APCS. And for each of those, what happens is we've got a number of puzzles, and for each puzzle, there's an approximate number of tries. Okay, not everybody solves the problem, so you get this jagged array, like this, for every contest. So it's about half of a matrix. But for example, the Imagine Cup September contest, which we hope to give you tomorrow, had 257 users, 24 puzzles. If we multiply it out at approximately 10 tries, it's 13,000 programs. We know that. So there it is. This is it here. An average try count across all of the puzzles, maximum try count, and total solved users were 1,581. It's big numbers just for a single contest, and We're running them all the time. So we want to give you that data, and we will give it to you tomorrow. And what it will be is just a whole bunch of programs, but they will be indexed by user so that you can go in across a particular user and find out how that person is progressing in programming, if that is the kind of thing you want to do. Lastly, we always look at gender. It's an important issue in anything we do here, I'm sure for you as well. And does this game contest appeal to men and women alike? So we asked the question on the that survey whether people were male or female, and they were free to answer that question. I don't think that's 682 is correct. I think it's meant to be, yeah, it is 682, sorry. So converted to percentage. So 80% of the people were male, 12% female, and then there were some who didn't choose. What's interesting is that almost equally, they played it for their own enjoyment, right? Or they played for a course in Java or a course in C#. Those were other questions. But this is the one that I really liked. So equally, they were playing for their own enjoyment. And more particularly, this 12% female tallies, in the US at least, with the current percentage of women in computer science courses. Now, I know that's going up, and I hope it will continue to go up. But when we took the survey, that was more or less the same. Now, we're going to go towards a course experience, and we'll be doing that tomorrow. And one of the places where we can do that is in Office Mix. And hopefully there will be time to have more discussions about Office Mix. Office Mix is part of Office. If you've got the latest Office, you can just download it as a plugin. And Code Hunt is there. We heard this morning that there are loads more Code Hunt courses. This is a simple little one that one of our interns did on strings. Alicia, she was a great kid. And so you do a whole PowerPoint, and right in the middle you can pop a Code Hunt slide, and you actually work on Code Hunt, and then you carry on with the slides, and then you come back to Code Hunt and carry on with the slides. So in summary, we've got a very powerful and versatile program. We've got large numbers. We need to really test more hypotheses on these numbers. We don't believe we've got all the questions or answers correct. We've only got some of them. We'd really like to talk to you about what we could do to hold up some of these students or players, what's going on in there. And finally, this course experience is probably our most pressing next step. As an advertisement, Imagine Cup are running their next contest for $1,000 starting on February the 21st, 4 p.m. in the USA Pacific Daylight Time, midnight UTC. So if you want to start with that, alert your students. Thank you. Yeah.
During your presentation, I whispered a question to Paley, and now I want to share it with you
Sure.
and the whole crowd, because I think it's important, and the summary slide hits it. I think as you try to move Code Hunt more into the course experience, the education experience, all this sort of stuff, there's a big unanswered question. To be clear, I'm not actually skeptical, but others will be, and it's a deep question, which is, does being good at Code Hunt mean you're good at programming? Does getting better at Code Hunt mean you're getting better at programming? I don't think there's any data in this corpus of data that helps answer those questions.
Yes, actually there is. Daniel's got some. evidence. So, yes, I think so. I remember a slide. So there is some evidence that progress is made when people are moving through the APCS course.
There's evidence that playing Goat Hunt makes you better at Code Hunt.
Exactly.
Yeah. That's not the same. That's not the same as evidence that playing Code Hunt makes you better at programming.
All right.
Or better at passing the AP test, which is arguably a different thing, but nonetheless still an open question.
Okay, well, that would be a very difficult link to make.
Yes.
Yeah.
I remember.
Tomorrow, in my talk, I will share some experience on using in my course. So that, not that huge amount of data, but close up to see what's going on. I think hopefully we could have some more discussion there.
And maybe you've got some as well, Alfred?
I hope to have some. I don't have enough. I haven't accumulated enough data yet.
All right.
But it's definitely something I'm very interested in, and
Sure.
it's a big focus.
I remember from the very first contest in China that people could use either Code Hunt or other ways to get into the final, right?
Oh yeah.
And in fact, the Code Hunt people did very well in the final, which was not Code Hunt.
Oh, yes, actually, they won the contest.
Yeah.
So there were 10 teams were invited to the finals, and the one that won the finals were actually a team which comprised of students who came in through the Code Hunt route.
And other people came in through more traditional ways of a programming contest, and the final was a more traditional programming contest, not Code Hunt.
Yeah. So, but my fuller answer to all of this is that there are many aspects to programming. And this is your serious coding aspect. And one of the things I think that...
so this is why I'm pushing back,
Yeah.
sorry,
Yeah.
is that Code Hunt is sort of unique in this, it's your
Yeah.
second bullet,
Yeah.
right? It's unique in trying to guess what the secret program is, right? It's very engaging, it's
Yeah.
very fun, it gets students to think in this very logical manner,
Yeah.
but I think there's a larger gap between that and what programming traditionally involves than the other pedagogic techniques that have been tried. I think there will be more skepticism in does this help do the traditional thing because it's more different.
So one of the criticisms that we've been hearing in education conferences which I've been attending has been that because students have been concentrating on teamwork and these other aspects of programming such as GUIs and softer areas, if one might put it that way, they can't reverse a linked list. They've lost the ability to do hard coding. And the pendulum had swung a little bit too far to the one side. And you often hear this from professors who have second-year students. What did they learn in first year? They can't code, right? So I think that it really is a mix, and there's room for a lot of aspects.
Yeah, but putting it that way, I think the interesting study, which I'm not signing up to do, but someone should do, is comparing a well-chosen set of Code Hunt puzzles versus sit down and write a program to reverse a linked list.
I'd love someone to do it.
Right?
So
That's the comparison, right?
If you have students
And then
these
what
kind of
would your
studies,
metric be? Would your
we're
metric be
interested.
time? Speed?
The metric would be the exam a month later.
The exam at the end of the year.
Okay. Well, that's for the educational research community, so we'll have to get them excited at the next Succeed, Pelly.
Right?
Yeah, I mean, should you keep it fuzzy and make it a game, or should you give the specification and...
Yeah, this is a particular game,
particular
right?
game.
This guess this program you can't see, right? And we're arguing that particular game has educational value, right? And that's there's some leaps of faith there.
There is.
So I want to just chip in one thing inside. The platform could be very powerful in terms of giving you flexibility, right? You should just disclose whatever specification in the code that you give into the course. So in practice, in the course that I taught, basically it's a mixture of both, right? I mean, for some problem, I just directly tell them what's the requirement. They just use it as a feedback engine to tell them what they went wrong, right? So, but for some other, you have branding, some guessing, to have a little bit more fun aspect of that. So I think it's a mixture there.
So in your user initial problem, you can put a massive comment, give a complete specification of the problem. That's not something we do in the regular gameplay, but you could think that as a teacher, you could just do that. And then go into a more traditional way where you know exactly what you have to build.
So I think related to that point, so there is this aspect that when we talk about a code hunt puzzle, we talk about it as if it were some uniform thing, but in practice there can be huge variety between exactly how those puzzles look like, how carefully they were crafted, with what goals they had in mind. And you could imagine running a study and getting completely different results depending on which body of puzzles you picked.
Oh, that's completely true. I mean, the competition the puzzles are very scrutinized, and it takes a lot of time. Ask Nigel how long it takes to get all these puzzles. It's tricky. But yes.
Yeah, I really like all these points, and particularly Tao's point that if I were trying to sell this to an intro CS instructor, I might first sell it as a great UI for PECs for fun, right? Give them some practice problems. When they get it wrong, they'll be shown a test case that doesn't work. They can revise, give them the spec. But if you want more engagement, if you want to set up fun competitions, there's kind of game mode, right? Again, this is not how I would sell it to the masses, but it's how, if I were trying to get it into a particular classroom, it's much closer to the traditional model, right?
The feedback I got from the TEALS teacher who teach APCS is it's more down to earth. They have zero time to invest. They're chapter 1.2. There's a website that gives them 1.2. That's where you go. And they use Practice It because of that, because it maps one-to-one to the book they're using. It saves them time. They don't really care about the interface or anything like that. It's just the time comes. And educational, a lot like that. Teachers make decisions not always because it's the best thing, because they have no time to spend with it. Sometimes maybe overfitting also what should be best.
Okay, so it gives me a lot of pleasure at the moment now to introduce Willem Visser. It's come all the way from South Africa via South America, which must be the longest journey to Seattle. And he's going to tell us about the slider bar you want.
Okay, thank you very much. My little joke about being from a few miles south, I wasn't quite sure it hit home earlier, so I had to put South Africa there at the bottom. And it's the very south of South Africa as well, which is probably even further away. Okay, so what I'm going to talk about is actually something very simple. I'm not quite sure how hard it is to actually do. It might be quite hard, but the idea is the following. So what you have at the moment, you have Code Hunt, and it's built on symbolic execution. And what you're interested in really is something sat or unsat, and then you need some solutions, because we need those solutions to be able to tell you or to guide the student or whoever to see what they are, what hidden specification they're trying to find. Now, what I'm going to talk about is something called model counting. And in model counting, what you're after is the number of satisfying solutions. So I'll show you in a second kind of what that means, but the idea is, can you use this to add a progress bar? That's the one slide summary. So just for these examples, we're going to go to a perfect world, which by the way is roughly the world we live in anyway in Code Hunt, because it's usually linear integer constraints, and it's the kind of stuff that symbolic execution is pretty good at. And it turns out that if symbolic execution is good at it, so is model counting, basically. Sorry. Yeah. Food's good. Food's always good. And we're going to work with uniform distributions, which is kind of important for these calculations. And again, in these examples, uniform distributions are actually what you want anyway, so it's going to work well. So I'm going to quickly, in about 1 or 2 slides, just recap symbolic execution, simply because this kind of symbolic execution that I'm describing here is actually the opposite of the kind of symbolic execution you saw earlier with PECs, because this is what's I don't know if it has a real name, but usually people call it like symbolic execution or classic symbolic execution because it's not dynamic. Dynamic symbolic execution is when you execute the program with concrete inputs and you collect some constraints as you go. In this stuff, you just start with the symbolic input. So I have a little program here, and I start here with 2 symbolic inputs, x and y, and my path condition or the constraint under which I reach that point in the code is currently true. So if I start executing, if I want to reach this S0 statement, never mind what it is, then the big Y, which was the input Y, needs to be equal to x times 10, the input x times 10. From S0, you can reach S2 under this constraint, which is a conjunction of the one you had plus this thing here. And similarly, you could have got to S3, and on the other side, S1 and S2 and S3. So basically, for all these locations, you execute the path through the code and you have a constraint. And basically, this is what we're going to be working with. These constraints are the constraints in the input to reach that point in the code. Now, if you're going to be doing just symbolic execution, you can now solve these constraints. In this example, they're all satisfiable, so that's not very important. But you can get these inputs like 1 and 10, 0 and 1, and 4 and 11. And this, for instance, will cover all these statements. That's kind of your vanilla symbolic execution. Now, what we're going to be after is a slightly different view of the world, where we start off with this big volume of values, and they're going to be flowing down the program. So here's an example of what I mean. So this is the same program, except now I have suddenly a range here of values. So I say x and y will be 100 values from 0 to 99. Then there's a barrier here in the beginning that's y equals 10x. Some of the values split this way, where it's true, and some of the values split this way where it's false. And similarly for this other if here. Now the thing is, though, this is not quite accurate, right? Because these rivers of values or flows of values, they're not equally distributed in this way, right? So a question would be, if you have these 4 paths, which of these are actually the most likely paths? Okay, so when I first looked at this, just blindly, I thought this one here looks like it should be the widest path. However, turns out this is roughly what it looks like. So actually, the most likely path is this one, and these 2 are almost equally likely, but it's very small sliver compared to all the values that go that way. Now, the question is, how did we come up with these magic widths? We used model counting. And there's a model counter called Latte that we're using. It counts the solutions for conjunction of linear inequalities. It works really very well. There's another one called Barnevik that Diego there is using. If I can get it to compile, I will also use it, but it's still a mission. But Latte works really well for what we want to do. Now, with this, we can actually calculate these values precisely. So for my little example here, 9,990 goes this way, and so forth, right? So this is the basic technology that we'll be using. So we have these constraints, these path conditions. They come straight from symbolic execution, so they're not mysterious. And what we're trying to figure out is simply how many solutions are there in each one of these. Now, what can you use it for? Well, program understanding, for one thing, to kind of give you an idea of what happens in your program. You can, of course, add probabilities to this because you know what the width of, or the number of values are. So you know there's, say, almost 85% chance of your program coming down this way. Once you have probabilities, you could use it for reliability. If you know something bad happens here, then you know this program is 3 nines reliable. This nothing to do with what we're going to talk about now. What we want to do is this. So can you add a progress bar? How wrong is the program? That's kind of the same question. And which correct program is better? Now, you heard already that the correct program is better spec at the moment is the number of instructions. So I'm going to kind of show a slight alternative to that as well. But that's actually not the most important part. The most important part is how do we rank incorrect programs. So the example I'm going to be using, this example I used before I heard of Code Hunt. And then since I've heard about Code Hunt, I've tried to also include some examples from Code Hunt. But the triangle classification is a classic thing in the testing community. You have 3 sides of a triangle, and you need to classify what type of triangle it is. I have four versions of this program, 2 correct versions, 2 buggy versions. The 2 buggy versions, the one I actually, or one of my colleagues accidentally created with a small typo. And the other one was from a coding exercise we gave our students at one point, and this other buggy version comes from there. Okay, so here's the correct version. This is kind of like a bit of an elaborate one. You really don't need to know what it does, except that the incorrect version just swaps around right here the greater and less or equal, right? So that's only little one character mistake that is in this program. Here's another correct version. You can see it's a lot more succinct than the first one. And the second buggy version is almost exactly the same logic as in this program, except that this big thing here actually misses a case. So there's a condition that's being missed in this example. But really what these programs do is somewhat irrelevant to the presentation. Okay, so now the first question you might have is, if you look at these two programs, which one do you think is better? Okay, I know the Code Hunt spec will say this one is better because it has a lot less instructions, right? Another way to look at it is to look at all the constraints of the different paths through the code. So there are these, I think, 13 or something paths here. And the color coding is not really very important, except that this is the different types of outputs. There, if you look here, there's like 4 outputs. Return 4, return, well, 1, 2, 3, 4 is the values it can output. And this is the color coding for those ones. For example, there's 99 here is the one where all the sides of the triangle is equal. The yellow ones are the cases in which it's not a triangle. Okay, now if you look, so this is for the first correct version, these are all the partitions, and this is for the second one. Now, the second one has less paths, and more importantly, it has less paths that are dealing with the case of the illegal triangle. So these yellow ones here are less. Now, it's not rocket science, lots of people have already mentioned this, but of course you can therefore use the number of paths through the code as an actual metric for which one of the programs are better. But that's the kind of like somewhat uninteresting portion of the talk, hopefully. Maybe this is going to be a bit more interesting. You saw this before, basically. This is the little harness that you use also in Code Hunt. This is my version of it. So for this specific program, it takes the 3 inputs. You run the buggy version, you run the oracle, and you assert that the 2 are the same, or buggy version or whatever, the student version. Student version against the oracle, and then you check if they're the same. And all I'm suggesting is to do the following. You record the path conditions for which this assertion fails, and then you see how big those partitions are. So how many values are actually going down this stuff. And that simply is going to be the metric for how buggy your program is. So now if we look at the 2 programs we have, the correct version, now of course here it doesn't matter even which of the correct versions you have, because obviously all the correct versions will have the same paths, right? So for the correct stuff. So therefore, if you look at the correct version versus the first buggy program and correct version, the second buggy program, it turns out the first one has about 62% of the input values are actually incorrect or incorrectly classified. Whereas the second program has a lot less, like 14% roughly, right? So when we looked at them syntactically, the one literally had 1 character mistake and the other one missed the whole condition. But the one with the 1 character mistake is actually remarkably wrong. Right? So this is somewhat unintuitive. I mean, you would have thought, since there's such a small syntactic difference, that it also would be a small difference in the number of behaviors. But in fact, it's not the case. So buggy 2 is in fact closer to being correct than buggy 1. Yeah, so this is just saying the same thing again. I mean, the edit distance between the one correct program and buggy 1 is very close. However, behaviorally, it's a big difference. And of course, you can just almost proof by contradiction think that there is no way you can use edit distance because you could have written a lot of different versions of the correct program. So how can you compare against that? Because you might be comparing against the wrong one. The small issue with this is all good and well, but intuitively though, if you're a user of this system and you see this progress bar and you literally have a 1 character mistake in your program, you might not appreciate the fact that the thing is going to tell you that you're way off, with your current program. So this is a potential thing one should consider. Now, as a sidetrack, I was kind of shocked when I saw that result. I couldn't believe that that small change in the program actually had such a big effect on the correctness of the program. And I thought to myself, well, this is a classic mutation operator. So there's this whole area in software testing where people, mutation testing is supposed to be something that people use to kind of evaluate the test suite. But what 99% of people use it for is as a metric to see how good your new yada yada bug finding technique is, right? Because you use it to just mutate programs and then you run your technique on this and try and see if it can find the bugs. So I was interested, or I'm still interested in seeing, but actually how much of an effect does the operators make in terms of mutating the program? Because if you have one mutation and it suddenly has a huge impact on the program, of course your whatever bug finding technique is going to kill that mutant because half the behavior of the program changed. So as a little example, here we have a one-line program. It just says I lesser equal to j. This is what you're trying to test. And here you have 4 mutations of that thing. The one is greater equal, that one is just missing the equal, this is just equal, and that one just returns true. So the question is, which of these do you think is the most wrong? Anybody? Okay, I think the third one, okay, I think I have one for the third, let's see. That one's only 1% wrong, right? Because it's only misclassifying the equality here. So that's pretty correct. Now this one is way off, right? And that's with the greater equal. Actually, the only thing it classifies correctly is the equality one. Okay, but now here are the 2 tricky cases. Which one of these 2 do you think is the most wrong or correct?
That's wrong 50% of the time.
Yeah, almost 50% of the time. But the funny thing is these 2 are actually the same. So it's like, this is wholly unintuitive in my humble opinion. So I think this could be actually quite interesting to look at further. But now let's play some code hunt. Now, this is one of the very early examples in the code hunt thing, might actually even be the first one. So the program, and I'm going to take a lot of liberty here with my syntax so the stuff fits on the slide, but this one takes x as input, and I give it a range from 0 to 9, so 10 values, and you're supposed to return x times 2. So my way of playing code hunt, maybe I shouldn't give too many hints away here because it's probably very stupid, but this is how I do it. I look at the results that I get from the kind of hint window, so to speak, and then I just cut and paste it into my program until I can see a pattern. So when I cut and paste this in, it says x equals 2 returns 4 and x equals 6 returns 12, so I stick that in there. And as you might notice, I stick it in just like that. I don't even change the return. And it turns out 7 of those values that flow through that program will be incorrect. Right? So basically 70% of my program is incorrect because 10 is the number that flows in there. Okay, so then I look at what the thing gives me again when I give this program. So it adds 1 more. So I add 2. If x is 1, then return 2. And at that point, I actually noticed that there's a comment that says, this return 0 is that's not usually the correct way to do it. That's what Code Hunt tells me. So then I try a next version. Slightly incorrect, but I decide maybe x plus 3 is the right thing to do here. And I expected this to be a better solution than the one I had before, but unfortunately, it turns out it's the same number of incorrectness. And what I failed to see was if I return x plus 3 here, I do cover the case where x is 3, but I actually lose the case where x was 0, because that was with this one. So I didn't actually improve my program by doing that. Okay, so another example, and okay, full disclosure, this actually happened. So what you're going to see next, stop laughing. So, and notice I don't tell you what the correct version is. We'll get to that in a second. So this is what the system output for me the first time around. It turns out there's 100,000 possibilities here and about 10,000 possibilities. X and Y were each a range of 100 values. So I was essentially completely wrong, except for the 3 that was actually there. So those 3 were correct because that's what the tool told me I should do. And then when I ran that, it gave me these two at the bottom here. So I added those, and suddenly another two of them fell away. So I'm like almost completely incorrect. And at that point, I thought I saw the pattern, right? If you look at these things, maybe the pattern is x minus y. Okay. Actually, to full disclosure, I did notice that these ones won't comply with that spec, so I wrote a little extra code to kind of cover those cases too, but never mind. And when I did this, I noticed that, okay, so now I'm about 100 values better off. So I'm slightly better. My program is slightly better. And then I kind of tried this one. And amazingly enough, I went backwards, right? Because here I decided, let's just take all this stuff out and just replace it here with the x minus y. That's probably a good approximation. Unfortunately, I lost two of my correct answers doing that, so I moved backwards. So then kind of like, what if we just fix the code so that if x is greater equal y, we return x minus y, otherwise y minus x. And then I chopped off another like 99 values or so. Point is, I'm still completely off, right? This is just, I'm completely wrong with this program because it turns out that was the actual correct program. It was x plus y. But cunningly, the tool always gave me a 0 in one of these things. So I thought, like in the beginning, it's the difference between these two values, but actually wasn't the difference. It was x plus y. And I'm hoping to see here that if you have this kind of scenario, you should see that you're so far away from the answer that you must change your approach, right? Clearly, you're heading in the wrong direction with your code here. Okay, so one last example. Oh, yeah, sorry, a small interlude. Yes?
Sorry, can you go back? But you could argue that you were very close to the solution, though, right? Because, I mean, the idea was right, you just had to reverse the sign.
Yeah, sure. But,
so it's hard to say, you know, when you're far and when you're close. But that's whatever kind of leads you towards the...
Yeah. It's the same issue that we had in the beginning with the one character that was wrong in the other program. I mean, syntactically, you're close to the answer, but unfortunately, semantically, you're a million miles away from it.
Yeah, I guess it depends on what helps you more, if it's being closer syntactically or semantically.
So I'd like to argue semantically.
I just would like to add a particular data point. I mean, as I mentioned earlier, we tackle this problem with a simpler solution. It's very interesting to later on we compare to see whether the simple solution will work. One way to use this is to use the behavior similarity metric to see whether you are overfitting. Okay? So you just like, oh, I just see this whatever table value you add in. You see incremental improvement rather than big jump, right? You want to see big jump because that's really you solve the real things. So it's another way to use the data as what you described.
Actually, the next example hopefully will show exactly that. Okay, so what happened at this point is I had to start to play Code Hunt because, as was pointed out, you can't skip ahead, right? So you have to solve all the puzzles until you get to the interesting examples. So time passed, and I played Code Hunt until the cows came home, except I was also in Brazil, so I did a few touristy things. But I needed to get to the interesting examples, and it really took me a while. But at last, here is one that I think is somewhat more interesting. So this is the correct version. If x is greater or equal than 50, you return false. Otherwise, you return true. The reason why this is 0 to 199 is I usually look at the first answers the tool gave me. And if it gave me answers above, say, 100, then I went to the next multiple. So that's why it's 200. The tool, PEC's result gave like 133 or something like that. So I went for 200. OK, so here's my first attempt. Again, it was a cut and paste from the original. And it turned out this was wrong on 49 values out of 200, so it's about 25%. And then I went for this version because, again, this is this is again a cut and paste just from what PEC's gives you. And this was wrong on 46 answers. OK, so basically, just because I added 3 more, actually, there were a few steps in between here where it gave other ones. So like 48 and 47 was really here as well. So 46 is wrong. So this is incremental. This doesn't seem to be really helping. It's just going a little better. Now, when it gave me this, it gave me 64 as a false. So then I thought, oh, well, maybe there's something here. Because at this point, I thought, modulo 2. This seems like it might be that. But when it gave me the 64, I realized it's not modulo 2. So I decided there must be some different way of doing it. So I decided to go with if x is greater or equal 64, then you return false. Unfortunately, that didn't really help. So although that was potentially a step in the right direction, it was the same number of wrong answers. But when it gave me this answer, it also gave me like one of the smaller numbers or something as true, like 2 or something as true. Then I thought, oh, well, maybe it's as simple as this. If x is greater or equals 64, else return true, rather than just enumerating. And that gave the big leap forward, because suddenly only 14 values were wrong. And actually, now, of course, from that 14, you can almost deduce what the real answer should be at this point, because 14 from that is giving you the 50 that you were actually looking for. So here you made a big step forward, and that should have been hopefully a big green flag that you're moving in the right direction. Okay, so this is the last example. So just to conclude, the bounds are, of course, now quite important, because if I don't have bounds, then I can't calculate these values. And by the way, all these values are calculated with a tool. Okay, admittedly, I had to cut and paste the programs into it because it's not connected to CodeHunt, obviously. But we have tools that do all this stuff. It's not a manually counting all the solutions. But the bounds are important. If I don't know what the bounds are, I can't really do this. But as I pointed out earlier, even when I played all these games, sometimes I would accidentally stumble upon the bounds, even playing CodeHunt. So, but it's even worse in this case, because somehow you must expose the bounds completely. The other question is, should we give like these raw scores, like the numbers I just gave? So like literally tell you that you are 94.3% wrong or something like that? Or should we give like more kind of like descriptive things, like you're way off, you're a little better, now you're getting there, something like that, rather than these precise numbers, because the precise numbers might put people off a little. It might not be so good. Of course, a progress bar that moves forward and stuff might be another alternative to this exactly. And the last question is, can we actually do model counting for all the different domains that is currently supported by CodeHunt? For most of them we can. Strings is kind of complicated, but there's been a recent paper on how to do model counting for strings, so hopefully this can also be combined. But one will still have to see if all the domains can be properly supported. And that's it.
Great.
So probably you mentioned briefly on the bounds. I mean, because quite some coding tools, you don't have that nice, small enough bound for the input domain. So that would limit, the applicable
Actually, the bounds is not that. It depends exactly what output you want to give, right? So in all these examples, I had a concrete bound there, and I gave concrete values and stuff. But you're not going to give concrete values. You don't need to. Then the bounds are slightly less important. The bounds must just be big enough. As long as the bounds is big enough, then you'll be okay. But the point is, this technique it cannot even start if you don't have bounds. So you absolutely must have bounds, because otherwise you can't count the number of solutions.
Right. So the techniques that we try basically very simple. One is the random sampling. Second is I take the reference program. We just use PEG to explore all the paths. Within the bound, right? And then the constraint, bound the constraint. Then you basically count how many paths actually fail on the student solution.
Yeah.
Right. And the third one just mix both, like the existing setting. So
yeah.
I'm just wondering, do you have any?
Yeah. So what
these techniques would fit these simple techniques.
Yeah. So what you just described is exactly. This is taking, like in your first example, you said just the paths. What this is also doing is taking the width of the paths into account, right? So that kind of plays an important role. And instead of sampling to see how many times you go down a certain path, this one just calculates it. So yes and yes. This in theory should do better if you can for sure apply the technique on that domain. Right, that's the only real caveat. As long as you're like an integer linear arithmetic, you're home and dry, it all works perfectly fine. Floating point, for example, is a different story, but luckily you don't support floating point here either. Strings is an issue, but like I said, there is ongoing work on that. So maybe if you introduce a feature like this, maybe from the get-go it won't work on all examples. Like only some examples will have a progress bar, not all of them, but yeah.
So, Willem, just to be clear, you do envisage that we might be able to have this sort of progress bar on the main page of CodeHunt. There is a possibility that the tools could integrate.
Well, PEX produces path cognitions. This thing just takes a path cognition and counts the number of solutions.
Right.
So the actual technical integration is relatively straightforward, I think. I think there are a few other issues one need to consider, like, for example, this discussion we had about this syntactic versus semantic, because it could be that it actually is not a helpful thing for people when they play the game. One will have to see if it's something useful.
So, I mean, based on our experience, it could be a mixture, depending on what kind of a game or what kind of student solution you have. For example, if student solution would be typically uniform, right, not too way off, right?
Mm-hmm.
I mean, then syntactic, distance would be okay. But if like you could write a loop or you could write recursion to accomplish the same functionality, syntactic distances would then work it well. Then behavioral, metrics or this kind of dynamic metrics could help better in that sense.
So so a couple of things. So one was with the syntactic semantic thing. So you said that you guys looked at the, I guess it's a question for everybody, at the whether it's, you want a big jump over, but is there any evidence that it's, so if you look at the way people get to, or the good players get to the solution, is that, what kind of, phenomenon do you observe in terms of getting closer?
So we did not really distinguish like good player or bad, but data is there, right? And we had this data, metric, we have behavioral metric using simpler techniques, right? And
because it would be good to, kind of to try that with your, with the counting and see whether, what's the evolution. And if you see basically that there's really this slope, then it's perfect. That it means that helps.
Well, do you think you would be able to work this out from the data we're going to be giving you?
We already, have results on the existing, the original Pick for Fun data.
Yeah.
So with the new data, definitely we could try it, and then we could have some discussion and see like what kind of pattern, what kind of question we could learn by looking at the data that we are going to get. Definitely.
Because in a sense, if you keep putting there the constraints, right, that's what you get. You get the slope that goes towards the right solution, right? But that's not what you want.
Yeah, but the issue would be like if you follow my approach to it, you add like 5 of these. You cut and paste like the first 5, say, and then hopefully you see the pattern. But in some of the examples, I didn't see the pattern, for example.
So I think sometimes it really depends on your strategy or trick, right? Like for the example that Willem showed, for me, I just, without really click one-time button, I just write a bunch of if statements from 0 up to 100. Right? Immediately you have big table, right? Then you look for pattern there. Just one-time click, right? So that does not mean, I'm better. It's just I master the strategy, right? I know how PEX work, what kind of data would be produced.
Risha?
With your Bayesian similar discussions, actually, we've been looking at more like syntactic distances, and actually, based on interaction with TAs and students, many times what happens is students would do everything right. It's just the common case where they get something off by 1. So there's off by 1 initialization error, off by 1 array indexing, and all the test cases fail. And I think that's where actually really you want to give feedback that you are really close. It's just that there's a small mistake in your program, even though all of the test cases are failing, you're getting 0%. So I think in some sense, maybe some kind of combination between syntactic distance and semantic distance is something what we need. To give good feedback.
Armando is next.
Yeah, and some of what we've seen is that this is very, very problem dependent, and that on the one hand, you have some problems where the common error is that you don't realize that there's a corner case that you're trying to handle, right? And this is the kind of case where this kind of model counting can be very useful because it can tell you, look, for most inputs you're doing okay, but there's this corner cases that you're missing. On the other hand, those are also the kind of cases where the counterexample inputs themselves are giving you a lot of the information that you need because they're going to tell you, you missed this corner case, you missed this corner case, you missed this corner case. So in some sense, this is not quite, one of the questions is this giving you information that is above what you can already tell by looking at the examples that you're getting?
Just in that one example, because I ran into that all the time when I played the game, is of course what happens now is you see like say 3 examples in the red crosses for 3 examples, but what you do not know is that those are the only 3 that you're still missing, right? So basically in this case, it'll actually give you that information. It'll say you're missing like say 1% of the cases, and then you might be able to see, oh wow, there's I can just add these and I'm done. But sometimes you add those and it brings you down from 99% wrong to 98% wrong. So it's not really getting you anywhere.
Yeah, especially cases where you have to generalize the corner cases, where the corner case is not just one input, but there's a family of examples where the system would help them. Did you make a jump or not after adding those more general corner cases?
Amen.
Yes, so another scenario where we have problem is a lab exam type scenario where a student has to submit several programs within time bound, and towards the end they try to make lot of changes and suddenly program stops compiling, and at the same time the time is over. Okay, so we get lot of programs which are not even compiling, but probably they are very close to the correct solution. Some semicolon is missing or some comment has been opened and similar type of thing.
Yeah.
So I think in that case syntactic thing will help.
Yeah,
but
sure.
Even there we have to find some way to repair the program first.
Yeah, that's true. He's been having his hand up all day.
So one of the things I think is interesting about this is I don't think it's actually either syntax or semantics that you're picking up on specifically. It's just number of paths. And
well, a width of paths.
Right, sorry, yes. Yeah. And I think one thing that there's a couple ways that you could present that information that I think wouldn't interfere with a person's flow. And one of them is to actually specifically say there's this many of this many paths correct. And another one would actually be to pair it exactly with the output that you're already getting and say, this many are left in this kind of category. Because it actually does sort of fit with those paths. So it might be worth considering.
Yeah, that's a good
way of presenting it.
Yeah.
Because it actually, I think, is consistent with what you're doing already.
So I'm going to have the last question, and that is, have you got a feel for the size of problem that this might be applied to?
Our experience so far has been whatever we can symbolically execute, we can count. Okay. But I do have my favorite next slide here. This is just our little framework for speeding things up. And it's really not much more than splitting up the problem into subproblems and storing the results persistently. So if you ever run the same thing again, the results are already there. And in a context like a code hunt, because thousands of people are playing the same game all the time, you can gain a lot by caching the results, and probably already caching results, but at least there's model counting results you can also cache, and therefore I would think for the size of things you're talking about here, you'd probably be fine with the model counting.
Great. Excellent. Well, let's have